You are standing on a surface that is 6,371 kilometers above something you have never seen and will never see, and roughly 100 kilometers below the beginning of a region that has no precise boundary and no ceiling. You are, right now, sandwiched between two systems whose scale, behavior, and strangeness are so out of proportion with the sensation of standing on solid ground that the floor beneath your feet constitutes a kind of lie. Not an intentional one, but the kind that arises when an enormous truth is compressed into something small enough to stand on. Press your foot into the floor. Feel the resistance. That resistance is the end point of a mechanical chain that descends through 6 layers of matter, each one more alien than the last, terminating in a ball of solid iron at a temperature exceeding the surface of the sun. Not metaphorically, not approximately, but measurably, verifiably, 4 to 5,000 degrees Celsius, in a sphere 1,500 kilometers wide, surrounded by a shell of liquid iron rotating at a speed different from the solid core beneath it and the mantle above it. The differential rotation between these two layers is what makes it possible for you to be alive. You feel none of it. You never have. And yet it reaches you, right now, invisibly, as a field. Look up. The sky above you is not empty. It is not even close to empty. It is a layered architecture of pressure, chemistry, plasma, and electromagnetic geometry that extends 400,000 kilometers into space before the boundary conditions become ambiguous enough that physicists argue about where it ends. Each layer has its own temperature regime, its own chemical composition, its own set of physical laws that dominate, its own relationship with the electromagnetic spectrum. The air you breathe is 45 kilometers thick above you. Above that begins a region where the temperature stops decreasing and starts increasing. The exact reversal of every intuition the word up normally carries, and the reason you are not being killed by ultraviolet radiation right now. Above that, a layer of charged particles that can be seen from orbit as curtains of light. Above that, the ghost of an atmosphere thinning into a solar wind that connects the surface of this planet to the surface of the sun. You are sitting at the exact center of a system whose depth and height together span roughly 400,000 kilometers, and the only part of it you can touch is the few meters of crust your body occupies. The question is not academic. The question is, what is actually there? The answer begins below you, because the below is where the physics starts. To understand what is beneath your feet, you have to understand the problem that seismology solved, and the person who solved the part of it that everyone else missed. In 1936, a Danish mathematician and seismologist named Inge Lehmann was working with data from a major earthquake in New Zealand. She was studying the shadow zones, the regions of Earth's surface, where seismic waves from a distant earthquake arrive in patterns that do not fit a simple model of a liquid interior. Everyone at the time knew that Earth had a liquid outer core. The shear waves, which cannot travel through liquid, disappeared at the right angles to confirm it. But Lehmann noticed something in the pressure wave data that the model could not explain. Waves were arriving in the shadow zones where they should not be. She proposed the simplest explanation that was still true. There must be a solid inner core inside the liquid outer core, whose boundary refracts the pressure waves at an angle that sends them back into the shadow zone at an unexpected trajectory. Her 1936 paper, published in the Bureau Central Seismologique Internationale, was 1 page long. It was titled, "With Magnificent Economy, P.E." The seismological community accepted it within a decade. The inner core was confirmed experimentally in the 1970s, and every detail she had inferred from wave arrival times turned out to be correct. What she had identified without ever going there, without any instrument that descended below a few kilometers, was a solid iron sphere sitting inside a liquid iron shell, both of them inside a silicate mantle that flows over millions of years like a viscous fluid, even though it appears solid on any human time scale. The physical principle at work in her deduction was refraction, the same bending of a wave at a boundary between two media with different propagation velocities that describes how light bends passing through a glass lens, or how the apparent position of a fish underwater is displaced from its actual position when viewed from above. Inge Lehmann used the Earth itself as a lens and read the bending of sound waves through it to deduce the existence of a structure smaller than the Moon, sitting at the center of the planet. The razor sentence for the structure below you is this: the Earth is a layered heat engine whose solid iron heart is kept solid, not because it is cold, but because the pressure at the center is so extreme, 360 gigapascals, or approximately 3 million times atmospheric pressure, that it prevents the iron from melting despite the temperature, and whose convecting liquid shell converts that thermal gradient into the electromagnetic field that envelops the entire planet. That last part is worth pausing over, because it is where the physics becomes something more than geology. The liquid outer core, roughly 2,300 kilometers thick, is in constant convective motion. Hot material rises, cools slightly, falls, reheats at the base, rises again. The Earth's rotation imposes a consistent twist on this convection. The Coriolis effect, the same phenomenon that determines the direction large storm systems rotate, acts on the fluid iron and organizes its circulation into helical columns aligned with the rotation axis. These columns of moving, electrically conductive iron constitute a current, not a metaphorical current, an actual electrical current, continuously flowing through the fluid outer core at speeds of tens of kilometers per year. And an electrical current, moving through a conducting medium, generates a magnetic field. This is not an analogy or a teaching simplification. This is the Maxwell equations applied to the planetary scale. The Earth's magnetic field is the literal, direct consequence of moving charge in the outer core, and it is maintained, continuously, by the thermal convection that has been operating since the planet formed 4.5 billion years ago. Consider the scale of this mechanism in terms of what it takes industry to replicate a version of it. A modern industrial electromagnet, the kind used in particle accelerators or MRI machines, requires precision wound copper coils, continuous electrical power input, water cooling to prevent overheating, and careful engineering to maintain field stability over hours or days. The field strength decays the moment the current is interrupted. The Earth's dynamo is self-sustaining without external power input, without cooling systems, without engineering maintenance. It has been running at continuous full output since the Hadean era, operating on the thermal energy of a planet formed from the gravitational collapse of a solar nebula, with no interruption except for the polarity reversals. Roughly every 100,000 to 1 million years, the north and south magnetic poles swap, the field weakening and then recovering over thousands of years, that leave their record in the magnetic orientation of iron minerals crystallized from ancient lava. The cost of replicating the Earth's dynamo, if you needed to engineer it from scratch, would be literally incalculable, because there are no engineering specifications that operate at the scale of a planetary core. The mechanism runs for free, and has been doing so for 4.5 billion years, and every compass needle ever made responds to its output. What this means for you, standing on the surface, is something the physics makes precise. You are not merely standing on a planet. You are standing inside a magnet, inside a dipole field that extends between 30,000 and 60,000 kilometers above the surface on the equatorial plane before being compressed by the solar wind on the sunward side and stretched into a tail hundreds of millions of kilometers long on the night side. Every compass needle that has ever been made responds to the same fluid iron circulation that Inge Lehmann inferred from her earthquake wave data in 1936. The mechanism connecting the solid crust beneath your feet to the magnetosphere above your head is a single continuous physical chain. Thermal gradient drives, convection drives, current drives field. This is the field, not the gravitational field, which dominates most discussions of planetary physics, but the electromagnetic field, the one whose presence defines the difference between Earth and Mars. Mars does not have a magnetosphere. Its internal dynamo shut down approximately 4 billion years ago when the liquid outer core solidified. The consequence was direct and irreversible. Without the electromagnetic shield, the solar wind began stripping the Martian atmosphere. Particle by particle, over billions of years, the lighter atmospheric gases escaped. The pressure dropped below the threshold at which liquid water is stable on the surface. The chemistry of any biology that may have existed lost the physical conditions it required. The entire surface history of Mars, its transition from a world with valley networks carved by flowing water and an atmosphere thick enough to support rainfall, to a cold, dry, irradiated desert with surface pressure less than 1% of Earth's, traces directly to the cooling of a liquid iron layer whose former existence planetary scientists can infer from residual magnetic signatures preserved in Martian rocks. You have that layer, you still have it, and you have never felt it. Subscribe and like this channel. The series continues with every mechanism this scale. The ones your body is sitting inside without knowing it. The ones that make your existence possible at the precise physical level of what they actually do. If the below is the story of heat preserved since the formation of the solar system and expressed as electromagnetic architecture, the above is the story of that architecture meeting something coming the other way, and the consequences of the collision. If you could travel upward from where you are sitting now, you would pass through 7 distinct regimes, each of which operates by its own physical logic. The first 12 to 15 kilometers, the number varies from 15 at the equator to 8 at the poles, because the equatorial atmosphere is warmer and extends higher before reaching the same pressure threshold, constitute the troposphere, the layer containing 80% of the atmosphere's mass and essentially all of its water vapor. This is where weather happens, not because weather is simple, but because this layer has the right combination of temperature gradient and moisture to generate the convective instabilities that produce clouds, precipitation, and the pressure differentials that drive wind. The temperature drops at roughly 6 to 10 degrees Celsius per kilometer of altitude. The adiabatic lapse rate, the consequence of expanding gas cooling as pressure decreases with height. This gradient makes the troposphere unstable and the stratosphere above it stable, and that distinction is not arbitrary. It is what keeps the atmosphere's chemical layers from mixing on short time scales, which is what allows each layer to maintain the chemistry that gives it its function. At the tropopause, the boundary between the troposphere and the stratosphere, the temperature gradient reverses. The stratosphere gets warmer with altitude, not colder. This temperature inversion is maintained by one molecule, ozone. Ozone in the stratosphere absorbs ultraviolet radiation in the wavelength range of 200 to 300 nanometers, the UVB and UVC bands that, without this absorption, would reach the surface at an intensity sufficient to destroy the molecular bonds in DNA at a rate that would make sustained life on land impossible. The energy of the ultraviolet photon is converted into heat by the ozone-oxygen photochemical cycle. UV photon strikes an oxygen molecule, splits it into 2 oxygen atoms, each of which combines with an intact oxygen molecule to form ozone, which is then struck by another UV photon, dissociates back to molecular oxygen and a free atom, releasing the photon's energy as heat. It is a catalytic cycle. The ozone is both consumed and regenerated, and it has been operating continuously for roughly 600 million years, since atmospheric oxygen concentrations became high enough to sustain the ozone layer, which is precisely the same geological moment when complex multicellular life became viable on land. That coincidence is not coincidence. The arrival of the ozone layer was a precondition for the colonization of land surfaces by anything more complex than a bacterium. The heat released by this photochemical cycle is what produces the stratosphere's temperature inversion, which is what makes the stratosphere stable, which is what keeps weather confined to the troposphere below it, which is what makes the atmosphere's convective mixing slow enough that ozone does not get diluted before it absorbs the ultraviolet that would otherwise destroy it. The ozone layer protects itself by creating the physical conditions for its own stability. This is not a design. It is a self-organizing system maintained by photochemistry, and it has been operating since before the first fish grew legs and walked onto land to benefit from its protection. What most people believe about the sky is that it is a passive backdrop, a region of air that exists between the surface and space, across which light travels and weather occurs, and above which there is simply nothing relevant until you reach other planets. What the mechanism reveals is something structurally different. The atmosphere is an active, layered, self-maintaining chemical system in which each layer's properties are consequences of the layer's position in a photon flux gradient, a temperature gradient, a pressure gradient, and an electromagnetic field gradient simultaneously. The sky is not a backdrop. It is the visible face of a four-dimensional coupled system that has been maintaining the surface conditions for complex life for over 500 million years, and whose stability depends on every one of its layers continuing to perform its specific photochemical and physical function. Remove any layer, and the consequences cascade through all the others. This is what modern atmospheric chemistry, starting with the work of Paul Crutzen, Mario Molina, and Frank Rowland in the 1970s on stratospheric ozone depletion, eventually made precise enough to change international policy. The chemistry of the upper atmosphere and the biology of the surface are not separate systems. They are coupled, and the coupling is the mechanism of habitability. Subscribe and tell me specifically what you were picturing when you looked up at the sky before watching this. Was it an edge, a layer, a gradient, or something that had no physical structure at all in your mental image? The difference between those answers tells me what the mechanism changed for you. Above the stratosphere, at roughly 50 kilometers, the temperature peaks at the stratopause and then begins dropping again through the mesosphere. The mesosphere is the coldest region on or near Earth, reaching temperatures as low as -130 degrees Celsius near its upper boundary at 80 to 85 kilometers. It is also the layer where incoming meteors ablate. Not because it is hot, it is the coldest region of the atmosphere, but because it is the first layer with enough atmospheric density to cause significant friction against an object moving at tens of kilometers per second. The object's kinetic energy converts to heat through collision with atmospheric molecules. The object heats, glows, and largely vaporizes before reaching the denser atmosphere below. Most of the material entering from space, dust, small rocky fragments, the continuous rain of micrometeorites that deposits 40 to 100 metric tons of extraterrestrial material on Earth every single day, every single year, without interruption for 4.5 billion years, is processed here. The accumulated mass of extraterrestrial material deposited on Earth over geological time is not trivial. Some geochemists estimate that a significant fraction of the trace noble gases and certain isotope ratios in Earth's crust were contributed by cometary and meteoritic bombardment. The boundary between your body and outer space chemistry is not as clear as it appears. At the mesopause, the temperature begins rising again through the thermosphere, starting around 85 to 90 kilometers up, climbing to between 500 and 2,000 degrees Celsius, depending on solar activity. At those altitudes, the atmosphere is so thin, less than 100,000th the density of surface air, that temperature measures the kinetic energy of individual molecules, not the rate of heat transfer to an immersed body. A spacecraft in the thermosphere experiences almost no thermal load from the atmosphere itself, even though the individual molecules nearby are moving at velocities corresponding to 2,000 degrees. The count that matters is density, not temperature, and the thermosphere is almost vacuum. The sensation of 2,000 degrees and the experience of 2,000 degrees are entirely different physical realities, separated by the question of how many molecules per cubic centimeter are carrying that energy and how frequently they collide with the object in question. Temperature without density is an abstraction. The thermosphere is also where the ionosphere exists, not a separate layer but an electrically active region overlapping the upper mesosphere and thermosphere, defined not by temperature but by the density of free ions and electrons. Solar radiation at ultraviolet and X-ray wavelengths carries enough photon energy to ionize atmospheric molecules, to strip electrons completely from atoms, producing plasma, a gas in which positive ions and free electrons coexist without forming neutral atoms. This plasma is a conducting medium, It reflects radio waves in certain frequency ranges, bending them back toward Earth's surface and allowing radio signals to propagate over the horizon and around the curvature of the planet. This is the mechanism that made long-distance radio communication possible before the existence of communication satellites, and it is entirely a consequence of the sun's ionizing radiation interacting with atmospheric gas at a specific altitude and density. The ionosphere was not designed for radio. Radio communication discovered, then mapped, then learned to exploit a property of the upper atmosphere that had been there since before any technology existed to detect it. Above the thermosphere, the exosphere begins. It has no sharp upper boundary. Individual molecules follow ballistic trajectories, moving in arcs determined by gravity without colliding with other molecules. Some of them escape permanently. Hydrogen and helium, light enough that their thermal velocities occasionally exceed escape velocity at those altitudes, leak continuously into space. Earth loses roughly 3 kilograms of hydrogen per second this way. The ocean contains enough hydrogen in water molecules to sustain this rate of loss for a time that exceeds the current age of the universe by several orders of magnitude. The leakage is real. Its rate is negligible on any scale shorter than astronomical time. The Earth is, technically, evaporating, and the rate is so slow that it is indistinguishable from permanent for any purpose except the deepest geological reckoning. The magnetosphere extends from the surface outward to where the Earth's magnetic field is strong enough to dominate over the solar wind. The solar wind is a continuous stream of charged particles, mostly electrons and protons, ejected from the Sun at 400 to 800 kilometers per second. When this stream encounters the Earth's magnetic field, charged particles moving through a field experience a force perpendicular to their direction of motion, the Lorentz force, which deflects them. The bow shock, roughly 90,000 kilometers upstream on the sunward side, is where the solar wind first encounters the magnetosphere, abruptly slowing from supersonic to subsonic and beginning to flow around the obstacle. The magnetopause, at 60 to 70,000 kilometers on the sunward side, marks the actual boundary of Earth's magnetic domain. This boundary fluctuates, breathing inward and outward with changes in solar wind pressure, and it is the reason Earth's atmosphere has not been stripped over geological time. The Van Allen radiation belts, two torus-shaped regions of high-energy charged particles trapped along magnetic field lines at 1,000 to 60,000 kilometers altitude, are not remnants of an ancient event. They are continuously replenished by cosmic ray interactions, solar wind penetration during geomagnetic storms, and neutron decay products from cosmic ray collisions with the upper atmosphere. They spiral along the same field lines generated by the liquid outer core that Inge Lehmann inferred in 1936 from the arrival times of earthquake waves measured at surface stations in New Zealand and Copenhagen. The chain from the inner core to the outer edge of the magnetosphere is unbroken. It is one physical system. Its inputs are the thermal energy preserved since the accretion of the planet. Its outputs include the survival of the atmosphere, the deflection of a stellar particle wind, the reflection of radio waves, and the possibility of everything that has ever lived on this surface. Here is what it means to hold all of this at once, which is what the physics actually requires. You are not standing on a planet. You are occupying a position within a system whose lower boundary is a solid iron sphere under 360 gigapascals of pressure at the temperature of a stellar photosphere, and whose outer boundary is the point several 100,000 kilometers above you, where the Earth's magnetic field becomes indistinguishable from interplanetary space. The physical distance between your feet and the center of this system is 6,371 kilometers. The distance between the top of your head and the nominal outer edge of the magnetosphere is approximately 400,000 kilometers. You are in position enormously closer to the center than to the outer edge, a fact your nervous system cannot represent and does not try to. The mechanisms that sustain your existence are distributed across this entire system simultaneously. The liquid iron convection that generates the magnetic field that deflects the solar wind that preserves the atmosphere that you are breathing, this is not a sequence of separate things. It is a single continuous physical process operating across scales that span from the atomic to the planetary. And the time scale of its operation makes the time scale of human civilization so small that honest comparison requires scientific notation. Human recorded history is 4,000 to 5,000 years. The liquid iron has been circulating for 4,500 million years. The ratio is 1 to roughly 1 million. Every political event, every technological development, every construction and collapse of every civilization in the archaeological record occurred during a single millionth of the time the outer core has been maintaining the field that makes human existence on this surface physically possible. The physicist's response to this is not existential. It is methodological. The question the numbers demand is not, how does this make you feel, but what did you believe before, and what does the mechanism correct? The answer is specific. You believed, almost certainly, that the sky was an edge, the place where the world ended and space began. It is not an edge. It is the outermost face of a layered electromagnetic architecture extending 400,000 kilometers, organized by iron circulating 6,000 kilometers below you, interacting with a particle wind flowing at 500 kilometers per second from a star 150 million kilometers away. You believed the ground was solid and passive. It is dynamically flowing in its interior at geological time scales, exchanging heat with a silicate mantle through which acoustic energy propagates at speeds of 8 to 13 kilometers per second. The energy whose travel time Inge Lehmann read in her data to deduce a structure that no human instrument has ever directly sampled. You believed you were inside something, contained, situated within a stable medium. The correct picture is different. You are at the interface of two open systems, each one extending over scales that dwarf the thickness of the crust you inhabit by factors of thousands and tens of thousands. The crust itself, the layer you stand on, the layer into which all human history is inscribed, is, on the scale of the whole system, so thin that a physicist describing Earth's interior uses it as a rounding error. The outer core is 2,300 kilometers thick. The mantle is 2,900 kilometers thick. The crust varies from 5 to 70 kilometers, thinner, relative to the planet's radius, than the skin of an apple is relative to the apple. This is where the geometry of your position becomes philosophically exact. You do not merely happen to exist on a very thin surface layer between two very deep systems. You exist because the very thin surface layer is the only place in the system where the thermodynamic conditions, temperature, pressure, electromagnetic shielding, atmospheric chemistry, lie within the narrow range that permits liquid water, stable carbon chain chemistry, and the kind of metabolic machinery you are made of. The habitability of the surface is not a coincidence of position. It is the specific outcome of the simultaneous operation of the planetary dynamo below and the photochemical architecture above, coupled in a configuration that has maintained itself, with interruptions measured in geological instants, for over 3 billion years of life on this planet. The extraordinary and the ordinary are not different phenomena. They are the same phenomenon perceived at different resolutions. The floor is not flat and passive and solid. It is the surface of a system whose dynamics extend through scales your instruments can measure, but your body cannot feel, maintained by processes that have been operating since before the Earth had a moon, organized by physical laws that apply identically here and at the center of distant stars. The sky above you is not a backdrop. It is a coupled photochemical machine that produces the atmospheric stability without which the surface would be uninhabitable within geological moments. Between these two machines, the one below and the one above, you exist at the precision interface where the conditions happen to permit the kind of physical complexity that can ask what is there. That is not a poetic observation. It is a measurement. The position you occupy is not a vantage point on a system. It is the only point in that system where the system can examine itself.